In this video, we are going to take a look at Unit 7, Lesson 11, and it is a new way to measure angles. What you're going to be able to do by the end of this lesson, hopefully, is calculate the radian measure of a central angle for a specific arc measure. So we're going to get you a specific arc measure, angle measure, and I would like for you to be able to calculate the radian measure. So we're going to start off by looking at page 217, and we are going to be given a circle with a 1 unit radius. So if you'd like a picture to help you, there's a picture of a circle with a 1 unit radius. We're going to want to find the arc length defined by these given central angles. So you've got 5 different central angles there. I'd like you to calculate the arc length. You might want the circumference formula, so I'm going to write that here for you if you've forgotten. So go ahead, calculate the arc length for each of those, then come back to the video. All right, so you could have done this in a variety of ways. I like to look at the total circumference of the circle given first. So we've got a radius of 1, so we're going to go do 2 times pi times 1, which is just going to be 2 pi. So the circumference of this circle that we have is just 2 pi. So that's the total circumference. And now we want a 180-degree arc, which we know is half of the circle. So we're going to do half of 2 pi, which is just 2 pi. Then a 45-degree angle, we've looked at that quite a few times, but it's half of 90. And we know that a 90-degree angle fits in 4 times, so 45 must fit in 8 times. So 45 is going to be 1/8 of our total, or 2 pi divided by 8 is another way to think about that. The whole circumference divided into 8 equal parts. And so 2 divided by 8 is 1/4. So we're just going to get pi over 4 units. Another way to think about that is that 2 pi is all the way around. So pi is halfway around. So the arc just for half the circle is pi. And 45 will split into that 4 times. But so a pi over 4 arc length for that 45. Then 270, so 270, a 270-degree angle is going to be 3/4 of the whole circle. And so 3/4 of, remember the whole circle is 2 pi. So 3/4 of 2 pi, you could do that a couple different ways. You can think of this as 6 pi over 4. And then 6 over 4 simplifies to 3 pi over 2. You can also think of the fact that pi is halfway around the circle. So pi divided by 2 must be each of these 90-degree chunks because it's half of pi. So just this part would be pi over 2, or halfway. So then we have 1, 2, 3 pi over 2s. 225, a variety of ways to look at this one as well. 225 is actually 45 degrees past 180. Okay, so 225, if we think of this as 180, this is another 45-degree angle. And we looked at each 45-degree angle as pi over 4. So we've got 1, 2, 3, 4, 5 of those pi over 4s to get into 225. So 5 pi over 4. You could think of it that way. You could think of that as 5/8 of the circle. So you could have done 5/8 of 2 pi. Okay, you could have done a variety of different ways for that. You could have done 180 plus 45. So you could have taken, oh, and I wrote that wrong. So it's a good thing we went back to this because that was supposed to be pi. Half of 2 pi is not 2 pi. Half of 2 pi is pi. So we could have added together pi and pi over 4 to get 5 pi over 4. So variety of ways to get that 225. And then 360 is just the entire circle. So the entire arc length or the entire circumference. So in this case, 2 pi units. All right, then in activity 11.2, we're actually going to get a whole script to read between Diego and Lynn. And so we're going to read over this script 3 different times, and I'm going to have you look for something different each time. So you'll be able to read it out of your book. You can also pause the screen and read it on the screen if you would like to. So this first read through, what I would like you to do is read this whole script. And while you're reading, what I want you to do is look for what the situation is about. So what are Diego and Lynn trying to do? So go ahead, pause the video, read that, then come back. So in this situation, Diego and Lynn, what they are trying to do is prove that the arc length intercepted by the central angle is proportional to the radius. So let me draw a picture of that quick. So the arc length from a central angle is proportional to the radius. So arc length would be here, intercepted by that angle, intercepted meaning between, okay? So between that central angle. So the length of that arc and the radius are proportional, meaning if we divide them, they will be proportional no matter how big the circle is. All right, then now I want you to read it through again, and this time I want you to think about important features of the circle, not actual measurements of them. I don't need specific measurements, just what are the important parts of a circle that Diego and Lynn talk about. So go ahead, pause the video, read it through, think about that, and come back. All right, so important features of a circle that they discuss would be the central angle, arc length, radius, and then scale factor. So for our final read through, after you read it through one more time, then I want you to go to the questions that are below this passage in the book, and I want you to brainstorm or just think about some responses to those questions. So go ahead, read through one more time, then read the questions, think about what you would respond, then come back to the video and we will look at it together. All right, so now that you have read through it, thought about what the whole situation is about, thought about important features of the circle, and then read through each question just to kind of get your bearings about what's going to be happening here, let's go ahead and look at this actual problem. So how does Lynn know that the big circle is a dilation of the smaller circle? And this is because all circles are dilations of each other, because we are always going to be able to find a number k that we can multiply this by to get to this larger, or the image radius. Because if we do image divided by original, we will always come up with that k. There is only one measure that makes a circle. So how does Lynn know that the radius in the image circle is equal to k times the radius from the original? And that's because that's the definition of dilations. So dilations, the length in the image in the second figure is always the original image times the scale factor. So the original radius times the scale factor will give us our new radius. And then what is Diego talking about in number 3? That this original arc length is equal to theta divided by 360 times 2 pi r. And this is just a way to write out the arc length formula that uses what portion of the circle are we doing. So the central angle always gives us the portion of 360. And then 2 pi r is our whole circumference. So we're looking at the portion of the circumference. Then Diego says that the arc length in the image is equal to the arc length from the original times k. So can we just, what is he talking about here? So we're going to take, what he's saying is we're taking the original arc length, multiplying it by the scale factor to get the image arc length. So the image arc length is equal to the original times the scale factor. So why is that true? So we know the lengths we can multiply by the scale factor to get the image length, but will that work with this arc length, and why? So why can we actually say that? So the proof behind this, or justifying it, is using that formula that Diego talked about. So Diego talked about that the arc length is equal to the central angle divided by 360 times the circumference, which is 2 times pi times the radius. So that's for this original image. Then if we look at the dilated image, the arc length is going to be equal to the central angle divided by 360 times the circumference, which is 2 times pi times the radius of the new image, right? So instead of writing R, capital R, let's write it with its dilated version. So R is actually equal to the scale factor times our original R. And then I'm going to rewrite this a little bit. Okay, so I'm going to leave this theta over 360 times 2 pi. But instead of writing k times r, I'm going to write r times k. And the reason I'm going to do that is then I notice that this arc length formula, okay, for the original arc length is actually here as well. So this whole thing we know, theta over 360 times 2 times pi times the original radius, is equal to the original arc length. So this I'm just going to substitute in the original arc length, which is just that little L. So the image arc length is actually equal to K times my original arc length. And that kind of just shows you that that will work. So this is true. So how did Lynn actually come up with that the original arc divided by the original radius equals the dilated arc over the dilated radius? So we can kind of use, we know that the dilated radius is equal to the scale factor times the original. And now we just proved that what Diego said is true as well, that the dilated arc is equal to the scale factor times the original arc length. So then let's just look at this. So let's do R divided by L. Or sorry, not R divided by L. They want to look at L divided by R. So let's look at L divided by R. And then we'll do L divided by R is equal to L divided by R for sure. So let's substitute in for L. What did we know L was equal to? Well, we know L is equal to, well, the large L is equal to the scale factor times the original arc length. And then what do we know the scaled radius or the dilated radius is equal to? We know that it's equal to the scale factor times the original. And then how could we simplify this? Well, we know that K divided by K is 1. So this shows us that the dilated arc length divided by the dilated radius equals the original arc length divided by the original radius. And that proves what Lynn is trying to show there. All right, so what does it mean for two quantities to be proportional? Okay, so that means that when they are divided, that they will equal out to the same number, or that there's a number that when multiplied to each, okay, that you can take the original and multiply it by that number to get it basically is a dilated version. There's some scale factor that you can multiply the original times that kind of scale factor will equal your new one. And so when you work backwards, okay, the new divided by the original will be that K value. Okay, so when we divide these, they will divide to the same number. And so that number is called the constant of proportionality. And so when we're looking at these two shapes, we said these are dilations of each other if they have this 90-degree sector. So let's take a look if we're looking for that constant of variation. So we've got in this first one, we're saying the arc length versus the radius. So the arc length equals some constant times the radius. So in the original, the arc length is 7 pi equals W times the radius. So if I divide by 14 to both sides, we would get 7 pi divided by 14. And 7 over 14 is 1/2. So we end up with pi over 2. So the arc length divided by the radius is pi over 2 in this original. So let's take a look in the dilated figure. The arc length is 10 pi. The radius is 20. Divide by 20, and we get 10 pi over 20. 10 over 20 equals pi over 2. So these two numbers divided to the same, okay? So 7 pi divided by 14 and 10 pi divided by 20 gave us the same number back because these two shapes are proportional. So how did this relate to our last activity? Remember, we looked at that. We said L divided by R, so the dilated length divided by the radius would equal the original arc length divided by the radius. And that's what just happened in this case. We got pi over 2 in both cases. All right, so we are going to take a look at the different another way to look at measuring angles. So first, let's talk about the different ways that there are that we could measure a person's height and a person's weight. So what are some units of measure that we use to measure height? And so that could be feet. We could measure people's height in inches. We could measure in centimeters. Okay, there's a variety of ways that we can measure somebody's height. And so like if this person was 5 feet 6 inches tall, we could also say that was the same as 66 inches. And then you could certainly convert that into centimeters as well. And so in centimeters, that would be about, let's see, 168 or 169 centimeters. But all of those heights represent the exact same, all of those measurements represent the exact same height, just a different way of saying it. And then same is true for weight. You could measure weight in pounds. You could also measure it in grams. And then you could get different numbers or different measurements that represent the exact same weight. So this is what we're going to be looking at now when we're looking at a different way to measure an angle measure. So currently we've been measuring angles in degrees. And so when you look at a circle, okay, all the way around a circle is 360 degrees. So 1 degree equals 1/360th of the circle, okay, of the whole circle. And so now we're going to look at a different unit of measure called a radian. And a radian is defined as the ratio, which means to divide. So the ratio of the length of the arc and the angles the circle's radius. So the arc length divided by the radius, that's going to give you your angle measure in radians. Okay, so taking the length of the arc divided by the radius. So on page 219, need you to do a couple of things here. So you need to have a piece of string. You need to cut this string to be the length of this radius. Then I need you to lay the radius around the circle, okay, and mark where it ends and draw the central angle associated and then calculate the radian measure. Then also work on numbers 2, 3, and 4. And this again starts on page 219. And then come back to the video and we will talk about it. All right, so you were going to cut a piece of string the length of the radius. So you should have cut the string, that long, however long it is in your book. And then move that string onto the arc. So pick the string up and then lay it down on the curve of the circle until it stops. Okay, so this would represent 1 unit because it's the same length as this radius. And then you could create the central angle here. So just connect the end of that arc back to the center. So then here's your central angle. So what would that be in radians? And so the radian measure of this is going to equal the arc length, which was 1, divided by the radius, which was 1. So our radian measure here, so this angle created is equal to 1 radian. So if we had a 180-degree central angle, okay, which would be a diameter. So if we had, here's the center and we've got this diameter here, what would use your string to approximate what this angle would be? So just keep laying your string along the edge here until you get to the other side of the circle. And how many string lengths did you need to put on there? Okay, so as you laid this down and kind of marked it off, how far did it go? And so it should have been a little bit more than 3. And 3 strings, so a little bit more than 3 strings. Remember, each string is 1 unit, okay, or 1 radian. So a little bit more than 3 units for the arc length here. Now we don't know exactly how long, but so if we're going to calculate the radian measure of a 180-degree arc, remember what we need is arc length divided by radius. So can I figure out the arc length of a semicircle? And so remember, this is half the total circumference. So if we did the circumference equals 2 times pi times the radius, which remember is 1. So the circumference just equals 2 pi. So this arc length, okay, so the length of this arc is half of that. So this is going to be a pi arc length. And then our radius was 1. So our radian measure is going to equal the arc length pi divided by the radius of 1. So the radian measure for 180 is just going to be pi radians. So what would it be for 360? And so 360 is just going to be the full way around, right? Which is going to be the full circumference for that arc. Okay, so your arc length all the way around the circle is just going to be 2 pi. The radius is still 1. So your arc or your radian measure is just going to be 2 pi radians. So could have done different strategies than I did in the video for that last problem. But what I looked at is just using the definition of the arc length divided by the radius. And I knew that the arc length of the whole circle was 2 pi. Certainly knew that the radius was 1. So that means that your radian measure is actually just going to be equal to the arc length, since we're going to keep dividing by 1. And so the radian seems to be connected to the radius, right? Since we're dividing by the radius here. And so it's connected. It's going to be proportional somehow with that radius. And so if we looked at different ways that this radius connected here, it would be that the radian really is how many radii fit in the arc. Or the arc length. And so how did our answers to the second and third questions connect? So remember, the second question was drawing the 180-degree central angle and then calculating the radian. Well, if we look at pi as a radian or as a decimal, so pi is really 3.14. And so we saw that 3, it was just over 3. Okay, so we saw a little bit more than 3 radii fit in, which is what pi is. So actually pi radiuses fit in this. What if the circle had a radius of 2 units instead of 1? How would the radian measure change? And the radian measure wouldn't change because the circle would just get bigger proportionally. So if we had a circle with a radius of 2 versus a circle with a radius of 1, okay, 1 radius. So here's your radius, here's 1 radius. Here's your radius, here's 1 radius. Okay, so it ends up creating the same angle. Okay, it's just that the circle is larger. We defined the radian measure as arc length divided by radius. So how does this relate to the idea that the arc length and radius are proportional? Well, if we've got the same central angle, so if you kind of look at this one, and we looked at a 90-degree angle earlier, so maybe we'll just keep looking at that. But when we did the arc length divided by the radius here, for this 90-degree angle, we kept getting arc length divided by radius, kept giving us pi over 2. Okay, when we did it in the smaller or the original, and when we did the large or the dilated version. Okay, we got pi over 2 for the arc length divided by the radius, which we now know is the radian measure of that angle. So it will stay the same for the same central angle. So let's take a look at this applet. So this applet kind of shows us some different things here, but it'll show us an angle measure in comparison to the radius. So as I change this angle, so you see this angle move, this is how much of the radius is going. So there's 1 radius. Okay, and then we'll keep going. That's 2 radii. There's 3. And then remember, when we go all the way or halfway, that's a little bit more than 3, which actually pi. So 3.14159. Here's 4 radii or 4 radians. Here's 5 radii or 5 radians around. And then all the way around is a little bit more than 6 because it's 2 pi. So it's going to be 6.28. So how does the applet picture describe what an angle with a measure of 1 radian looks like? So if we go back to it, okay, 1 radian, that radian is the same as the length of the radius, right? So this arc and this radius are exactly the same length. How would a 3 radian angle look? Okay, so it's going to be equal to 3 radii. So a 3 radian angle is going to be equal to 3 radii, or almost halfway. How many radian would a 90-degree angle measure? Okay, and we talked about that one. And we've looked at it a few times, and we know that it's going to be pi over 2. And we know because half of a circle is pi, so half of pi is pi over 2. So 180 degrees are halfway around the circle, and pi radians are the same. And then half of that would be pi over 2. And then how does this fit with the applet? So think about if we do 3.14 divided by 2. Okay, so we're thinking of like half of pi is going to be like 1.6-ish. Okay, or halfway through there. And remember, pi was representing all the way around, or about 3 radii, right? So then 90 is going to be like 1.5 radius or radii, which looks about right here. Can't get it quite at 90, okay? But we see 1 and about a half of another. All right, so get this written on your reference chart, what a radian is. So remember, it's the measure of the angle where the angle equals the arc length divided by the radius. So radians are another way to measure angles. We know that we can write the radian measure as the arc length divided by the radius. So dividing arc length by radius. And we know that this ratio is constant for a given angle, no matter what the size of the circle. So whether it's for a 90-degree angle, a 45-degree angle, 180-degree angle, and then no matter what the radius is, they will stay the same. So a 180-degree arc is always equal to pi radians because it's halfway around the whole circle, no matter what the circumference is. When we do that, circumference divided by the radius, okay, or half the circumference divided by the radius, we'll always get pi. And then another way to think of radian measures of an angle is that it's the measure of the number of radii that would fit in. Okay, so 1 radian is 1 radius. So this green radius would be equal to the length of this blue arc. So if we're thinking, what's the radian measure? It's how many radii will fit into that arc. All right, so you can go ahead and calculate the radian measure of this 60-degree angle using any method that you would like, including sketching a circle diagram, whatever you want, and then just explain your reasoning. If you are struggling with it or need any help, be sure you reach out to your teacher.